We've seen many of MATLAB's operators now, but we haven't yet seen how to determine the order in which they are applied in an expression. Well, the order is determined by two sets of rules, precedence and associativity. We'll look at precedence first. We ran into precedence earlier in this lesson when we used both transposition and the colon operator in the same expression. We had a surprise then, you may remember it. The transposition operator, which was written after the colon operator, was actually applied before the colon operator. It just transposed the 5, which did nothing. Transposition went first because it ranks higher than the colon operator. To make the colon go first, we had to add parentheses, like this. Those parentheses forced the colon operator to make the row vector first, so the transposition operator could then make it into a column vector. Well, let's look at a more familiar example, one involving arithmetic. Here the multiplication operator is written after the addition operator, but it's applied before the addition operator. So 3 is multiplied times 4 first to get 12, and then 2 is added to get 14. It's not the left to right order shown on the right, which would result in 5 times 4 equals 20. Here again, the non-left to right order happens because the operator on the right outranks the one on the left. This time it's multiplication, which is ranked higher than addition, and it goes first. In programming, we call this ranking precedence, and we say that multiplication has a higher precedence than addition. Having multiplication go before addition seems like the obvious thing to do because that's the way we've always done it. But with other operators, it's not always so obvious. So how do we find out the order? Well, we use a precedence table. This is a precedence table for all the operators that we've covered so far. Starting at the top, we find the parentheses, which have a precedence of 0. Next, we have exponentiation and transposition, which both have a precedence of 1. Before we look further, it's important to note that lower numbers actually mean higher precedence. So parentheses with their 0 precedence always operate before all the other operators in an expression. Coming in at 3, both multiplication and division come before addition and subtraction, which are at 4. Down at the very bottom is the poor old colon operator, which explains why it came after the transpose. At the number 2 position, you may be wondering what unary plus and unary minus are. Well, unary means that the operation involves only one operand. Here's some examples of unary operators. Up there at the top, plus 2, minus x, and h transpose. Unary operators tend to rank high in any programming language, and in MATLAB they're at positions 1 and 2. But the more common operators are the binary operators, which mean that they take 2 operands. And here you see some examples. 3 minus 4, x dot star y, which you will remember is array multiplication, x star y, which is matrix multiplication, and a to the 3rd power, which is exponentiation. The binary operators rank below the unary operators with the notable exception of exponentiation, which is way up there at 1. Well, we've seen how precedence works, and we've seen that unary operators tend to come before binary operators. But there's one other determinant of order of operations, associativity. Associativity is simpler than precedence, and we'll start with a very simple example. 6 plus 2 plus 3. A computer can carry out only one operation at a time, so it adds the 6 to the 2 to get 8, and then it adds the 3 to 8 to get 11. The order is left to right. Simple, but what about this? 6 minus 2 plus 3. Which goes first, the minus or the plus? We need to know because the results will be different, 7 or 1. Well, maybe the precedence table will give us the answer. No help. They both have the same precedence, 4. So here comes associativity to the rescue. In programming, the order in which operators of the same precedence are executed is called associativity. In MATLAB, it is always left to right. So we say that MATLAB uses left-to-right associativity. As a matter of fact, so most all other languages do. So this expression evaluates to 7. Here are a couple other examples. 6 divided by 2 equals 3. 3 times 3 gives 9. Both of these operators have a precedence of 3. And the last expression, 6 to the 2 power is 36, and 36 to the 3 power, well, we'll have to ask MATLAB. Whatever it is, I'm sure it's a pretty big number. So let's do that, in fact. Let's ask MATLAB to evaluate some expressions that require it to use these rules. Okay, let's start with the first example we did to illustrate precedence. 2 plus 3 times 4. As promised, multiplication has the higher precedence, so the actual order is like this. The redundant parentheses show that the 3 times 4 goes first. And that gives 12, and we add 2 to 12 and get 14. And if we force addition to go first with parentheses, we get a different result. 2 plus 3 equals 5, and 5 times 4 gives 20. As I mentioned before, we're used to carrying out multiplication before addition, even when addition is written first in the expression. Let's look at something that's not so familiar, the colon operator with addition. So I'm going to type 1 colon 3 plus 10. Surprised? Well, remember that the poor old colon operator has a lower precedence than all the arithmetic operators. To be specific, the colon is at 5 while addition and subtraction are at 4, and smaller numbers go first. So this is what we did. The 3 plus 10 went first, so we're given the colon operator 1 colon 13. If you want to add the 10 after the colon operator has made its row vector, you need to force it with parentheses like this. There, we got 1, 2, 3, and then we added 10 to each element and got 11, 12, 13. And by the way, note that we're adding a scalar to a row vector. So this is an example of a scalar being added to a matrix. In this case, the matrix has just one row. But as for any matrix, the scalar is added to each of its elements. If you don't know which operator goes first, you have 3 options. 1, use parentheses to force the order. 2, try an example and learn the order. Or 3, look at MATLAB's precedence table and read the order. So where is this precedence table? Well, it's right at your fingertips. Just type help precedence. And there's MATLAB's precedence table. You'll note that there's no parentheses here. Well, MATLAB just figures it's easy for you to remember that parentheses always go first. We showed that they always go first by giving them a precedence of 0. You'll also note that there's some operators here that we haven't looked at yet. Well, we'll get into them in later lessons. Now let's look at some examples of associativity. Once again, we'll start with the same example that we used when we introduced the subject. 6 plus 2 plus 3. The actual order is like this. 6 plus 2 parentheses plus 3. Because as we've seen, MATLAB always evaluates from left to right when the operators have the same precedence. And of course, since we have 2 pluses, they have to have the same precedence. But you can't tell with addition. If we force right to left order with parentheses like this, we get the same result, as you knew we would. When the right to left order gives the same result as the left to right order, the operator is said to be associative in both mathematics and computer science. So addition is associative. Well, what about this? The actual order is like this. The 6 minus 2 goes first because at the risk of being boring, or perhaps I should say even more boring, MATLAB always evaluates from left to right when the operators have the same precedence. If we force right to left order with parentheses like this, the result is different. So subtraction is not an associative operation. And when we mix subtraction and addition, which have the same precedence like this, since they have the same precedence, the order is, well, you know, I just can't bear to say it again. Now let's look at multiplication and division with this example, which we've seen before. And let's use a pair of redundant parentheses to make the order explicit. This one sometimes surprises people because it might look like multiplication should go first. It doesn't. That's because division and multiplication have the same precedence. So the order is determined by MATLAB's left to right associativity rule. Oops, said it again. If we force right to left order with the parentheses, the result is of course different. And finally, I sense that you are burning with curiosity to find out what 6 to the 2 to the 3 equals. Well, as promised, I'm going to ask MATLAB right now. 6 to the 2 to the 3. Since the left-hand caret goes first, this is 36 to the 3rd power. And as I guessed before, it's a pretty big number, 46,656. But just out of curiosity, what would the answer be if the 2 were raised to the 3 power first and then 6 were raised to that power? Well, we'll have to use parentheses to find out. 6 to the 2 to the 3 power. The result is different, which shows that exponentiation is not associative. And the result is a really big number. Let's see, that's 1,679,616. Kind of amazing you can get such a big number with just a 6, a 2, and a 3. Well, I guess I'd have to say that's the power of exponentiation. Get it? The power of exponentiation? Well, on that hilarious note, we've reached the end of Lesson 2.